Hi grade 11s, we're on to my favorite part of financial maths, which is topic 4, which is timelines. We're going to do a couple of examples together, I think there are about 6, just to look at all the various things that they can ask you. So let's look at example 1, and this example is one where they change the interest rate. So this question says 14,000 Rand is loaned from Saba Bank. Interest is 16% per annum compounded monthly, so that's a nominal interest rate for the first 6 years, and then it changes to 13% per annum compounded quarterly. What is the balance of the loan after 10 years? Now, I'd like to use this example to show you two different ways to do it. The reality is, the first way that I'm going to do it is very much a grade 10 method, and one which grade 11 questions, if we do them that way, they become incredibly difficult to do. And then I'll show you a second way, which is the way we prefer to do grade 11 questions. So first of all, let me draw myself a timeline. This is a fairly easy timeline, but they can get quite complicated. So basically, we invested 14,000 Rand. Something changed after 6 years, and we want to know what the balance is after 10 years. So what were my interest rates? My interest rates for the first 6 years was 16% compounded monthly, and then it changed to 13% compounded quarterly. So divided into 4 equal payments for the year. Now in grades 10, you probably would have been taught that you start with your amount at the beginning, which is 14,000 Rand, and I think I added an extra, I think that looks like 140,000, so let me take away 0. So 14,000 Rand, and basically you move that money. I call it moving your money, but you find out what that money is worth when something changes. Now that could be maybe another investment, or it could be a withdrawal, or in this case it's a change in interest rate. So in grade 10 we're very much taught to start at the beginning and move that money, basically find out what it's worth when something changes. So basically that would be saying that I'm going to take 14,000 Rand, I'm going to add interest at 16% per annum compounded monthly. Now for 6 years monthly, that would be 72 months. Now in grade 10 we would have told you to stop, put that in your calculator, and actually work out what that equals to. Now I get an investment value of 36,332 Rand, and now because this isn't our final answer, we need to keep all our decimals. So now I know how much money I have after 6 years. So we would have then taught you in grade 10 to say, right, let's start again. Let's move that money now to where something changes. Now nothing changes here, so I'm going to move that money all the way to the end. So now we say I have 36,332 Rand and all these wonderful senses, 626, and I'm now going to add interest at 13% compounded quarterly, and just be careful, there are 4 years there, and 4 years of 4 times a year will be 16 quarters. Now, don't forget to use the answer button on your calculator so that you actually don't have to re-put in that horrible number. You can just go answer 1 plus 0.13 divided by 4 to the power of 16. And I get 60,608 Rand and 94 cents. And now I can round off because it's my final answer. Now that's one way to do it. Now in grade 10, timelines are fairly simple, and so you could always do it that way because the questions are quite easy. When we get into grade 11, we're going to get some of these examples which are really complicated if you want to stop in the middle and work out money. So what's the other way to do it? The other way to do it is basically to start with your 14,000 Rand, add on interest, and instead of pushing equals and actually writing down the value, just keep on going. So what I mean by that is you would still start with your 14,000 Rand. You would still add on interest at 16% compounded monthly for 72 months. Now this equals that 36,332 Rand. Now there's no point in pushing equals because look, I'm simply going to put it down below as the new kind of p-value, and I'm going to multiply it by a new bracket. So this idea is, instead of actually writing this value down, that value is that. So why can't I just write the next bracket of interest and keep on multiplying? So now this p-value of 36,000 blah 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 needs to be added interest at 13% compounded quarterly for 16 quarters. So it is exactly the same concept. It's just that we don't pause to push equals and actually work out our A value at 6 years, because I'm just going to then use that as a new P value and continue with another bracket. And so you will get exactly the same answer, but you don't actually have to stop and write it down. Now it's very useful because you go straight to 60,608 Rand and 94 cents. So I'm really hoping that you're going to start feeling more and more comfortable with this particular way of doing it, especially as the questions get more difficult. Don't forget, if you're ever struggling, you can go back to the grade 10 way if you've tried the grade 11 way and it's not working for you. But let's try work more with this idea of continuing to go without pushing equals. Okay, let's look at another example. This example is what happens if you change deposits. Now again, I'm going to look at a different way of doing this compared to maybe grade 10. So this question says 5,700 Rand is deposited into a savings account. 2 years later, a further 1,900 Rand is added. A final deposit of 4,100 Rand is made after 5 years. 5 years after the initial deposit. So you've got to just be careful, is it after 5 years after the 2 years? But this said 5 years after the initial deposit. If the interest rate, so now we're changing interest rates, if the interest rate for the first 3 years, so this interest rate is 13% compounded quarterly, and then it decreases to 11.2% compounded monthly, how much will be in the account after 8 years? So now I know that that is 11.2% compounded monthly. Now, the reason why we don't like the grade 10 approach is, the grade 10 approach is start at the beginning with your 5,000 Rand, find out what that 5,700 Rand is worth when something changes. So we would do a calculation to work out what it's worth at time period 2. So that would be my first calculation. Then we would say, okay, I'm adding 1,900 Rand in, and we do a second calculation because we're adding 1,900 Rand. Then we would have to move our money and find out what it's worth where something changes. So that would be at time period 3. Then we would change our interest rate. Then we would find out what that amount is worth where something changes, and that's at 5 years. Then we would add on 4,100, and then we would do a further calculation to the end of 8 years. Now that's a lot of calculations, a lot of pushing equals, a lot of typing in decimals and writing decimals down. So can we do it an easier way? Okay, now there's a couple of really important things to write down before we start. Probably the most important thing someone will ever tell you in financial maths is that 5,000 Rand 10 years ago is not worth the same thing as 5,000 Rand now. So money changes kind of worth, which means you can't say I invested 5,700 Rand in the beginning, but 2 years later I added 1,900. So can't I just add the amounts together? Because this 5,700 during this time, that's 2 years, it's earning interest. So when you get to 2 years, you no longer have 5,700. So you can never add 5,700 and 1,900 Rand together, because those amounts aren't at the same place in the timeline. So the most important thing I'll ever say in financial maths is you can only add and subtract money when you know what it's worth at the same time. Now this is true in financial maths in life. You can only add and subtract money if you know what it is worth at the same time. So never, ever, ever add various amounts together unless you know what it's worth at the same time. Okay, so that's why the grade 10 approach of finding out what your 5,700 Rand is worth at 2 years, then adding 1,900 Rand is a valid way of doing it. Now here's the grade 11 approach. What the grade 11 approach says is, it doesn't matter if you put 100 Rand into one account for 10 years and 100 Rand into a second account for 10 years, if they got the same interest rate, how much money would you have at the end combined? That would be the same thing as just putting 200 Rand in the one account for the whole time. So it doesn't matter if you treat your amounts separately and then add them at the end. So what we would do here is you treat each amount separately, you find out what each amount is worth at the end, and then add them up. So I'm just going to write that down as a note as well. So what we're going to do is we're going to treat each investment separately and find out what they're worth at the end, individually. So let me say they are individually worth, just have to spell that correctly, individually worth at the end. So that in this case, that would be at the end of 8 years. Then we would add them together. Now let me just quickly show you why that is true. Let's just pretend that we had two 100 Rand notes. In one case, what happens if we put 100 Rand in at an interest rate for 1 year? And then we put a second 100 Rand in a completely different account for 1 year at the same interest rate. Is that the same thing as putting the amounts together at the same interest rate for 1 year? Now, just convince yourself mathematically that this is true, that these two are equal. Because if I look at this where I've treated them as separate amounts, basically I could say I have 100 in the bracket plus 100 in the bracket. So it's almost like I have 100 x's plus 100 x's is 200 x's. So it's 200 in the bracket. So just mathematically, it completely works out. Another way to think of it is if you think of this as 100 Rand and 100 Rand, each multiplied by the bracket, would you agree that I could distribute? I could say that each of those 100 Rand has to be multiplied by the bracket. So very importantly, it doesn't matter if you treat the amounts separately. I'm just going to erase this so I can write here. It doesn't matter if you treat the amounts separately and add them together at the end. So if we look at this, it makes our calculation much simpler, especially considering what we learned in the previous example. So what we're going to do is we're going to take 5,700 Rand and we're going to find out what that amount is worth all the way at the end. So let's try that. Calculation number 1 is to take 5,700 Rand. It was in the account at 13% compounded quarterly for, let's see, 3 years is where the interest rate changes. So there would be 12 quarters. Now, as we learned in example 1, instead of pushing equals and finding out what it's worth there, we just keep on going. Then the interest rate would be at 11.2% compounded monthly. Now, from 3 years to 8 years is 5 years. So that'll be 60 months. Now, I probably wouldn't even work that out. I would just say, great, let's actually first work out what the next amount would be. So my next amount is 1,900 Rand. Let us find out what that would be worth individually all the way at the end. So if I take 1,900 Rand, it was in the account at 13% compounded quarterly. Now it was only there for 1 year, from 2 years to 3 years. So that's 4 quarters. And then again, we don't push pause, we just keep going. 11.2% compounded monthly for the full 5 years. So that's 60 months. And finally, let's go and take our 4,100 Rand, which was simply in the account for 3 years at that second interest rate. So that's 4,100 Rand. It wasn't in the account for any of the quarterly interest rates. It was only in there for 11.2% compounded monthly. And I think it was 3 years, from 5 to 8. So that's 36 months. So we treat each amount separately and find out what it's worth at the end using this technique that we found out in example 1 of adding all the interest at once. Now these were all investments. So I now know what they're worth after 8 years, so I just add them all up. So I can actually put that entire thing into my calculator and only ever write down one answer. The only thing is you have to be really careful when you're typing, because it's very easy to make a mistake, and just always make sure that you check it twice. Okay, now just be a little bit careful. The longer you type on your calculator actually starts to become quite slow at responding. So the amount of times that I wrote 0.112, but because I typed it so quickly on my calculator, it actually is 12. So what I often do is I write the first kind of term, and then I push equals on my calculator. Then I write answer plus, write the second term, and then I push equals on my calculator. I don't actually write down the answers, but it's just that the longer you get into an expression on your calculator, the slower it is at responding. So I checked that 4 times, and I got 3 different answers, so I'm hoping it's 24,108 Rand and 19 cents. Okay, now that's considered a fairly difficult timeline, because you've got 3 different amounts and different interest rates, but I find it much easier to do these in the grade 11 type approach. Okay, let's look at some more. What happens if you did deposits and withdrawals? So 120,000 Rand was invested in the bond market for 5 years. Okay, so 5 years. 120,000 Rand is invested. The interest rate is 11.25% compounded quarterly for the first 3 years. So let me write down my interest rate. That is 11.25 compounded quarterly, and then it changed to 9.75. So just be careful, it's 0.975, not 0.9, compounded monthly. One withdrawal of 40,000 Rand was made after 18 months. Now, I prefer to keep my time periods in years, because I always just, it always means years to me, and then I can figure out how many quarters in 1.5 years. So I definitely wouldn't write 18 months, because that interest rate is compounded quarterly. So how many quarters is 18 months? So I prefer to keep my time periods in years. Calculate how much money is available at the end of 5 years. Now we're going to follow the same approach here. We're going to take 120,000 Rand, and we're going to say, right, if you invested it that whole time, how much would it be worth right at the end? So that would be 120,000 Rand. The interest would be 11.25% compounded quarterly for 3 years, so that's 12 quarters. And then, as we learned in example 1, we don't push equals because we can just keep going. Then the interest was 9.75% compounded monthly. Now that was 2 years, so that's 24 months. So you just have to keep your wits about you a bit. Now this 40,000 Rand, which is actually I'm going to subtract this in the end, but it's 40,000 Rand, and now this is where I think people get a little bit confused. Why am I moving this 40,000 Rand to the end if it didn't actually earn any interest because you removed it? The reality is, within this 120,000 Rand, if I move it all the way to the end, there's 40,000 Rand in there that shouldn't have been there. It was never gaining interest because you withdrew it. So what we're doing is we're now moving 40,000 Rand to the end to find out what would 40,000 Rand be worth at the end of 5 years, because I must take that entire amount away, because 40,000 Rand and all the extra interest that it did not earn because it was removed. So 40,000 Rand, now I've got to be a little bit careful, that's 18 months, that's 1.5 years. Now in 1 year there's 4 quarters. So in half a year there'll be 2 quarters. So this is 6 quarters. Now that again makes sense, because if there's 12 quarters in the whole time period, 6 quarters would be half the time, and 1.5 is half of 3. So it only needs to gain interest at 11.2% compounded quarterly for 6 quarters. Then it will gain interest at 9.75% compounded monthly, and that will also be 24 months. Now the reality is I am subtracting that 40,000 Rand with all the interest that it didn't earn. And again, I would just plug that into my calculator and check multiple times and write down one answer. So I did check this multiple times, and I get a final amount in the account of 145,902 Rand and 52 cents. Okay, so we're getting there slowly. Let's look at our next one. Loan repayments. A loan of 140,000, so that isn't written very well, is taken out and repaid as follows. Okay, so let me draw my timeline. I am repaying a loan of 140,000 Rand. It is paid after 1 year, I pay 55,000 Rand. 25,000 after 3 years, so I'm assuming that's 3 years from the beginning, so 25,000 Rand. And after a further 5 years, so that will be at 8 years from the beginning, because it says a further 5 years. So a further 5 years after 3 is after 8 years. He pays the final outstanding amount. So I'm going to put an X there because I don't know how much it is. Interest is 15% compounded monthly the whole time. 15% compounded monthly. Can we find the final repayment of the loan? Well, if he makes the final outstanding amount, that means he must have paid it off. So my kind of plan of action would be, let's take my 140,000 Rand. Let's find out what that loan would have been worth all the way at the end. Then let's take my 55,000 Rand payment, find out what it's worth at the end. Then let's take our 25,000 Rand payment and find out what it's worth at the end. And surely then I must take the loan, subtract the two payments. And when I push equals, that should be the amount that I still owe. And they said that he pays that final amount. And so whatever that answer is, I'm assuming should be my X value. So let's look at this a little bit more slowly. What I was saying there is, let's take 140,000 Rand, the loan, and let's find out if you added 15% compounded monthly for the entire time. So that's 8 years. So 8 times 12 is 96. That would be what the loan would be worth at the end. Now, what would 55,000 Rand be worth at the end? So that's 15% compounded monthly. Now that would be in the, okay, now let me just be careful. I can't say in the account. Remember why we're doing this. 140,000 Rand, we've added on interest for 96 months. But the reality is we paid some of that. We paid 55,000 Rand after a year. So there's a whole 55,000 Rand in this original sum that shouldn't have been there. And so that 55,000 Rand was gaining interest that entire time, but I'd already paid it off. So I need to now find out what that 55,000 Rand is with all its interest, because I need to remove that entire thing from my loan. So 55,000 Rand, that's 7 years of interest. So 7 times 12 is 84. And then finally, we made a payment of 25,000 Rand, and I need to add on interest for 5 years, which is 5 times 12, which is 60. Now my argument is that my balance of my loan will be my loan subtract my two payments, and that should give me my balance. And this question says he pays that balance outstanding with the final payment, and so that answer of my balance should be the final payment he makes to pay off his loan. Okay, so again I check this multiple times and I get 252,541,11. Now that sadly makes quite a lot of sense, because he loaned 140,000 and he only paid off quite small amounts. It is a little bit scary that his loan managed to gain so much interest, and I'm afraid that's the power of compound interest. Now if you got a negative balance, you definitely knew something went wrong, because he hadn't yet paid off his loan. Great. Let's look. I think we've got 2 more. Example 5 says, a loan of 30,000 Rand is repaid as follows: 10,000 Rand after 3 years, X Rand after a further 2 years, and a final payment of 2X Rand 10 years after the loan is granted. Now this is a classic example of why we teach the grade 11 approach to timelines, because if you didn't use the grade 11 approach in this question, it becomes ridiculously difficult. So let's have a look. You have a loan of 30,000 Rand. It is repaid as follows: after 3 years, you paid 10,000 Rand. X Rand, a further 2 years later, so that's after 5 years, you paid X Rand. And a final payment 10 years after the grant was let me say that again. A final payment of 2X 10 years after the loan was granted. If interest is 13% compounded annually for the first 4 years, so my interest rate is also changing. This is a fantastic question. So my interest rate over this time is 13% compounded monthly. Then it changes to an interest rate of 11% compounded quarterly, can I figure out what x is? So let's look at our plan. I'm going to follow the same type of plan as the previous question. This 30,000 Rand was a loan. Can I find out what that loan is all the way at the end of 10 years? Then, can I find out what this 10,000 Rand payment would be worth at the end of 10 years? Can I find out what this X Rand payment would be worth at the end of 10 years? And then this payment of 2x, I know what it's worth at the end of 10 years because it's 2x. Now, they say a final payment of 2x Rand. So if I know what my loan is and I subtract all these payments at the end, what should my answer equal? And I think my answer should equal 0, because if this final payment of 2x actually pays off the loan, then my balance is now nothing. So in the previous question, we actually had to work out the balance of the loan because we paid that balance. Here, they say they made a final payment, and so I'm assuming the balance of the loan after these 3 payments after 10 years is going to be 0. So let's try and look at this. What would my loan be worth? My loan would be 30,000 Rand. I would gain interest at 13% compounded monthly for the first 4 years. So that's 48, I think, 4 times 12, which is 48. Then if I continued, it would gain interest at 11% compounded quarterly for 6 years, because from 4 to 10 years, that's 6 years. So 6 times 4, because it's 6 years of 4 times a year, is 24. Now what are my payments? My payment number 1 is 10,000 Rand. And I need to add on interest for 1 year at the monthly interest rate. So 13% compounded monthly for 1 year, so that's 12 months. And then I need to do 6 years of the 11% compounded quarterly, so that's the same bracket as before. Then there was a second payment of X Rand. Now this is going to be a little bit more interesting, because X Rand I have to just keep as X. Now, it was not in the account, it wasn't paid at all while there was a monthly interest rate. So it's just going to have 5 years of the quarterly interest rate. So that's 11% compounded quarterly. And for 5 years, so 5 years of 4 times a year would be 5 times 4, which is 20. And my third payment is 2x. Now, that 2x, what is it worth at the end of 10 years? It's worth 2x, because we are at the end of 10 years, it was paid then. Now my argument is, if I take my loan and I subtract payment number 1 and I subtract payment number 2 and then I subtract payment number 3, I think my balance should be 0, because then I've paid off my loan. So I can actually make this an equation. Now if I look at these two are numbers, which means I can actually work out what that is as a number. These two have x's in them. So what I'm first going to do is put in my first orange line my 30,000 Rand at 13% compounded monthly, and then carrying on with 11% compounded quarterly, and I'm going to subtract the line below it in blue to get one number of the amounts that I know I paid. So assuming I did this correctly, I get that these two lines subtract to 74,671 Rand, 5718. So because I actually could work that out, what I'm now saying is if I have 74,671 Rand, 5718, what I'm going to do now is I'm going to work out this term. That's obviously something x. So if I work out that bracket, that 1 plus 0.11 divided by 4 to the power of 20, that's just going to be the coefficient of x. So I get minus 1,720,428,431 x's. So all I did was work out the bracket, and that's the coefficient of x. And then my last term is just minus 2x. Now I'm arguing that calculation has to now equal 0, because my balance of my loan is nothing. So now this basically becomes like an equation. So I can add these two together because they're like terms. So this actually gets me 2x plus 1.7 blah 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 will actually get me minus 3 comma 7 to 0 blah 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 x. So I'm going to take that to the other side of the equation. So to make it positive, so I get 3 comma 7 to 0 4 2 8 4 3 1 x must equal this loan of 74,671,5718. And now all I need to do is divide both sides by this 3.720. So I would try and keep that on your calculator. It's very useful so you don't have to write it in all the time. So I take my 74,671 Rand and I divide by that 3.72 and I'll find the value of the x. So I get the x value is 20,000. Oh, no, that was too many zeros. So let me undo that. 20,070 Rand and 69 cents. Now you can always go check. I could just go insert that for x in each of my payments and then push equals and check that I get 0, which is a great way to check that I did get this right. Now I did exactly that. I went and put in my 20,000 Rand for my x and I did that entire calculation again. I know it takes me a couple of minutes, but it's worth doing so. And I got 6.09 times 10 to the minus 3. So basically that's 0.000069 cents. Now that is just because we rounded off. And so I'm comforted to know that I did this correctly. Okay, let's look at our last example. Okay, now just to note, example 5, I should have said this, when we started it. Example 5 is considered an incredibly difficult question. Most of your timeline questions are very much along the lines of example 1, 2, 3, sometimes example 4. Example 5 is incredibly difficult. It's good to expose yourself to questions like that, but please don't for a second think that timeline questions are all going to be like that. Now the same with example 6 here. I chose this one because I thought it was nice and interesting, but it's very much not a stereotypical timeline question and would be considered as highly complex. So this question says, a man has a son aged 7 and a daughter aged 11 who share the same birthday. He wants to make an investment now so that each child will receive 7,000 Rand on his or her 18th birthday and then 10,000 Rand on his or her 21st birthday. Interest is 16% per annum compounded semi-annually. What is the amount he must invest now in order to fulfill his plans? So this is really, really complicated. So here I am now, and he has a son aged 7 and a daughter aged 11. And on the 18th birthday, now obviously I'm assuming the daughter will turn 18 first. Now if she's 11, she will turn 18 in 7 years' time. So after 7 years, he wants 7,500 Rand to give his daughter. Now, he also wants to give her money on her 21st birthday, so she will turn 21 in 10 years from now because she's 11. And he wants to give her 10,000 Rand on her birthday. Lucky her. Then the boy, who is 7 years now, that means that it'll be 11 years until he's 18, where he'll need 7,500. And then he'll only turn 21 14 years from now. So 14 years from now, he'll need a further 10,000 Rand. And he's earning interest this entire time at 16% compounded semi-annually. So this is 16% compounded twice a year. How much must he invest now? So I want to know what X is. So this is my original amount that I'm looking for. Now there's multiple ways to do this question. This is an incredibly tough question. Probably the easiest way to do this question would to be, now remember you can never add money together if you find out what it's worth, unless you find out what it's worth at the same time. So maybe an easier way to do this question is to look at the 7,500 Rand and find out what it's worth at the time of 14 years. So what would it have been worth? Then take this 10,000 Rand and find out what it would be worth at the end at 14 years. I always find it easier to move money forward, to add interest to it. Can I take this 7,500 Rand and move it to the end? And basically, then can I say, if this was going to be a lump sum payment at the end of 14 years, what is the final amount that he would need. Then I'll go worry about how X features into this. So what I'm going to do is, let's pretend that 7,500 Rand was needed at the end of 14 years. So that was 16% compounded semi-annually. Now from 7 to 14 is 7 years. So 7 years twice a year would be 14. My next one is 10,000 Rand. So 10,000 Rand, what would 10,000 Rand be worth at the end of 14 years? Well, it's 16% compounded semi-annually, but that's 4 years. So that's 8 sets of interest. Then 7,500 Rand for the son. What would it be worth at 14 years from now? So that's 3 years worth of interest, which is 6 semi-annual interest time periods. And finally, my last amount of 10,000 is simply worth 10,000 Rand because it's at that time. So what is this total investment kind of future value that he would need? So let me add all of these amounts together to find out what's the lump sum of money that he would have needed 14 years from now. So when I add those together, if you were thinking of this as one lump sum at the end, he would need 62,439 Rand, 81171. Now, of course, he doesn't need that because he's paying money off, but I'm finding out what all that amount would be equivalent to after 14 years. Now, how does this relate to X? Well, he's making an investment. So his investment, his principal amount is X. I need his final amount to be equivalent to 62,439 Rand, 81171. If my interest is 16% compounded semi-annually, and how many times would he have gained interest? Well, we're pretending that he invested this money the entire time, so that's 14 years, so that's 28 semi-annual interest time periods. Now, this isn't actually what's happened in reality, because he pays the 7,500 and the 10,000, during this time. But mathematically, this is going to work, because I have found out what all of these money that he wants to save toward is worth at the end of 14 years. So what would he have to save now to make that investment work out? And so now I say 62,439,81171 is equal to sum original investment if I added interest at 16% compounded semi-annually for 28 time periods. So I'm going to work this out, this bracket, and basically divide my 62,000 by it, because it's the coefficient of X. And I get the fact that he would need to have invested 7,237 Rand and 63 cents now. Now that's quite amazing. That's quite a small amount that's going to allow him to give his children such wonderful gifts. Now let me just state this again. This is a very difficult question, because none of this is what happens in reality. It's just the idea that mathematically you can equate things as long as you find out what they're worth at the same time period. So a very, very difficult question. Not a common timeline question, but nice to expose yourself to one of the more difficult ones. Okay, so that's the end of timelines. They really are fun, and please don't be thrown off by these last two examples. I deliberately chose ones that were more interesting just to expose you to them, but most of the timelines that you'll see in past tests and past exams are much more along the lines of example 1 to 4. Definitely a type of section that needs a lot of practice.